Well, good afternoon, everybody. It's a beautiful day today, and I am here in Arlington, Washington. And I was invited to come out and take a look at the manufacturing facility for MidNite Solar. So I'm going to take you along as we walk through, take a look at their different setups that they have, look at all the different things that they do for their different products that they sell right here in Arlington, Washington. So let's take a look together.
I'm Jim Hollenberger, Vice President of MidNite Solar. We've been in business for a little over 20 years now. Started out making combiner boxes, E-panels for a lot of the different other inverters that are out on the market, and started to move more into electronics with the Classic about 12 years ago. And then about 4 years ago, started moving also into the inverters. All of our products right now are really set up to be standalone as individual, which we'll continue to support. We've also started to support the mobile market, both with mainly with the inverters for RVs, trucks, but our main focus has really been coming up with equipment that is for people who live off-grid, and making sure that they have sustainable power and can continue to trust their equipment and keep them running. Right now, we're continuing to look at more additional growth with looking at our own all-in-one, and we have new product lines in our product map for charge controllers and other varieties of inverters. Historically, we've really always been an engineering-based company. In fact, probably at some points we've had probably more engineers than we've had other types of employees, good or bad. But they really get into researching, understanding the different technologies, how they work together, and they are very much driven to find solutions to no matter how minute that issue could be, they want to find a solution. The positive out of that is that they have been able to develop some incredibly powerful circuits that they have designed into these boards. For one, all we use now is SIG FETs. We've gotten away from using big toroids. Our latest inverter, the little Rosie, which is a 4,500 watt inverter, weighs 15 pounds. So it's very easy to move around, especially if you have it in your vehicle, like an RV or something. It's not adding a lot of weight to it. And we have found that it's very reliable. They switch much faster at a higher frequency, and it allows them to really last a long time. So Robin was the founder of MidNite Solar. Robin has been in the industry for well over 40 years. He was part of Trace Engineering, starting Outback, and he has helped out with Magnum Energy. And so all of those companies were actually right here in Arlington. And then when he started MidNite Solar, he partnered with a lot of those companies, and it was a very tight-knit group as they developed different products. Robin was still helping out because they've been partners. They've been partners for this whole time. In fact, that's why he built a lot of the E-panels for Outback and for Magnum and for Schneider. It was not just a business model, but it was something that those companies needed as part of helping to sell their products, and Robin was worked with them and helped them out. So Robin's expertise and his knowledge, because he's also an engineer, has really helped develop, making sure that we are developing products that really help people in different ways as the industry has continued to grow.
So we're walking right now through what MidNite refers to as SMT. And this is where a blank circuit board gets each electronic component added to it.
So you have a PCB board that's blank, just like this. And this will be an SPD. And then there'll be a matching stencil that goes with that. So then we have a stencil. So if we look at the board, and then this would go underneath it, and you see the cutoffs for all the little parts, which go to the parts. The stencil sits underneath it, and then it comes and it will smear across the top, and that will put the solder paste in each one of the pads.
So this is one of many pick and stack machines that will take the individual components and place them on the solder paste that was put on the circuit board from the previous step.
So this is AOI.
We have a golden board that we put in. It scans that board and uses that board as a reference. Then when we send in our new boards, it compares the two. So if there's any differences between the two boards, it'll flag that for me to review. And then I visually review the boards, making sure that they are either true calls or if it's just a false call. Right now the machine's just scanning all the boards, taking pictures of them. And on this screen I can see right now there's going to be 2 issues. And so it's telling me that the joint on this LED is off and that that one of the joints on this resistor is off. So going in, that looks like a great connection to me. Need to make sure. The fact that that's reflecting a lot of light directly back at the camera and not dispersing it as much as the other side, I would want to take a quick look at that under the microscope just to make sure that it's not a bubble forming there. No, that's a great connection. The dispersion of light is great, and I can see that it's covering that whole side of the resistor. So that's acceptable to me. Finish. And now it gets the
And then
stamp.
you stamp it.
So the size of the components is just amazing if you think about what the machine checks. It looks big on his screen, but in reality, these components,
They're tiny.
They're just very, very, very small. Yep. So they do all the surface mount stuff, and then it goes to somebody that has to physically do through-hole solder work.
Okay.
Old school through-hole, which is what these ladies do, who are very skilled at what they do. So depending on what product they're working on, there's a sheet that she goes by, and it specifies exactly what component goes where, and then she has to manually put them there and make sure that they're all facing the right directions. So it's like she's doing some transistors, it's like on there.
Some LEDs, and then this is the first step that I do with the SPDs. Then they get on the tree, sit there for a little bit until I get enough, and then I unbox my models.
Yep.
So it all depends on the model. So we got 4 different types, so we got 3 different mobs.
Yep, you want to show them what the 600 miles look like? That's the secret sauce that does all the work in the SPD.
So we got that one.
These are the parts that will absorb the voltage transients and explode.
Okay.
So these are the parts that are contained within the polycarbonate.
This is the 300.
So they got the dots. So like the other parts, they come they go through the SMT's process, so all the small stuff gets put on, and then she has to do all the through-hole stuff. And then once the through-hole stuff is done, then it'll go over to the wave solder machine.
After the wave, they go to building 10 and to another area where it has the rest of everything. So they'll put down the switches, inspect it, put in the wires, then they'll put dip it in conformal coating so it protects everything. And then we'll put bottoms on it, and then there's a plug to help seal it. And then we'll put silicone on the bottom piece, and then we'll put the lid on it so it's completely sealed, waterproof.
So from there, they'll move over to here, and they'll go through an oven where it will basically dip just the bottom of it, wave solder machine, to solder those components onto the board. And it has to be done that way so you don't unsolder all your pick-and-place parts.
Right.
We'll put it off to the side, let it cool down, and then we'll re-put it in. So I'll just leave a few touch-ups and
So these boards have been conformal coated, and she's going to put them in the oven. So
Yeah, show us what you got, young lady.
This on the paint.
Okay.
So it's had the conformal coating put on them. See, she comes over here,
And brushes it on.
brushes it on. Thank you.
Thanks a lot. You too. As we walk into this next building, we'll get to see where a lot of the assembly happens after the PCBs and all the soldering happens. This building is where all the components come to get put together to become their final product.
So it's 70 employees now.
Okay. How many buildings do you guys have right now?
5.
5? Okay.
So this is the kid line. We have Kenny, Eddie, and Danny. So have you been to SMT and AOY? You've already been there?
Yep.
Okay. So once they go through those stations, they get conformally coated, and then they head over here. And right now, Kenny's prepping for the board to go into the casting. What are you doing, Eddie?
Testing high pot on this unit.
Explain high pot.
Testing for shorts. If this machine goes off, it will say there's a short somewhere on the board. Run it for about 5 seconds, start it or turn it off, run it again, run it for another 5 seconds. And if it doesn't show this fail light right here, it passes. So that's good. And then I mark it off that the unit's been tested. And then I continue with the labels on it.
Eddie, will you show them where you're at in the work instructions?
Yeah. I'm on this page right here. I just marked it off, my name, and then I'm here on the last page with the labels. And then this is done with this step, so I go on to the next one. This is finishing off, or part 2 after high pot. So I put the bushings. And then I put the fuse covers. And then I finish off with the rest of the labels. Okay, and then that's the last step besides checking off on the checklist. Check my initials. And then send the unit off to the next station.
The next spot.
Yep. Which would be testing, which is right over here. And then this is testing, which is handed off to Danny. Danny can take it over. Go and explain what you do.
So here we hook up a harness that connects to this, connects to power supplies, and here we run a high voltage test and run it for 6 minutes. And basically it's just making sure all the numbers are stable. It's 3 screens. And we scan a unit, the barcode, and we check for the software version. So right now we're just waiting for the timer to end, and we watch, make sure nothing weird comes. 40 amps, so 0-30 for loads,
Okay.
and 40 amps for battery.
Very cool.
When it goes to drop that board, I'm gonna let heat sink here in a minute.
Yeah.
So do you guys get to jump stations often so that you're not doing the same thing over and over?
Yeah. I'm mainly between these two. Some people are mainly jumping around between 3 or these two as well, but yeah.
Is there any one that you like more than the other?
I would say this one. Either this line specifically, more than the other ones, just because it's a lot simpler.
Yeah.
So you don't have to. There's not as many steps to it, but so it means you can't fail. You know.
Yeah.
Yeah.
How are you, man?
Not bad. How are you?
Good. This is a Rosie breaker box.
So in this station, a pair of Rosies are connected together. One is discharging while the other is charging. They run that way for approximately an hour, and then they switch roles. And this allows them to easily test more units together, but also minimize the power requirements needed for testing multiple inverters.
What are you checking?
We're just making sure that they're plugged in the right way, and they're all the way down.
Seated?
Yeah. Okay. Just because everybody touches this with their, sometimes we might have like fingerprints all over. Mm-hmm. Wipe it out with alcohol.
So we have quite a few of these different machines, but over across the street also have a bigger wire. But this is cutting them out.
So we got to walk through the engineering department and take a look at things that go on behind the scenes. And then we got a chance to sit down with Andy, who's one of their engineers and also responsible for some of the firmware at MidNite Solar.
So Andy, how long have you been with MidNite Solar?
I've been with MidNite for 14 years now.
And mainly involved with the Rosie, or
I started with Rapid Shutdown and the Birdhouse. That was my first product. And then from there I did Arc Fault. And then from there it was inverters. And it's been inverters for about 10 years now. And then finally, of course, we got the Rosie, little Rosie out about 4 or 5 years ago.
Yeah,
So that's been...
Little Rosie.
That's been a lot more interesting.
Impressive.
Yeah.
Little Rosie is an impressive box.
Little Rosie's kind of perfect. She came together just, it was just sort of a juxtaposition of fates. It just all came together perfectly. All the choices that we could have gotten wrong, we got right. And it's just the most wonderful little inverter I think we've ever made. So I hope that customers receive it well.
Well, it's amazing that the SIC FETs on that make that machine so small. I mean, that's and so light. That's any reason that you decided to use SIC FETs instead of like every other company out there using the cheap standard MOSFETs?
Yes, so we use the silicon carbide transistors. They're just the best transistors you can buy right now for this. The insulated gate bipolar junction transistors that you see in a lot of these other inverters, they're lossier and more delicate and far cheaper. And so, yeah, we use silicon carbide FETs in the little Rosie, and it weighs about 1/5 of what the competition weighs at the same power level.
And in regards to our charge controllers and the big Rosie, they're all also SIC FETs?
Yes. Yeah, we use silicon carbide pretty thoroughly. That is a big differentiator. Also, our high frequency topology. Bobby Gudgel came up with a pretty good topology. He invented the power conversion system we use to convert power from the AC to the DC. I think that's the secret to our surge power as well, is between the silicon carbide FETs and the fact that we're synchronous. We have synchronously connected power from the DC side to the AC side. We deliver power to the loads almost instantly.
Yeah, there's no doubt that the Rosie and all these products have huge surge compared to any of the other inverters out there. I mean, 3x surge, and you and I have both seen them. If you take the limits off, they'll do 5x surge and run.
Oh, yeah.
Just want to eat themselves without blowing up. I mean, basically the solder will melt off of the board before they'll die. So
yeah, that's the other reason we like silicon carbide FETs, is they can operate at higher temperatures, and so they will often be the last thing that breaks. The solder will have to melt first.
Yeah. So you do all the firmware for all the products?
I'm currently developing all the firmware for the inverters. I don't do the firmware for the charge controllers. I think James is heading that up now.
Awesome.
But yeah, I do all of the inverters firmware. I've been working on updates pretty continuously for the last couple years. We just keep adding more capabilities and refining things.
If a customer comes up with a good idea that you put to the boss on a change, how hard is it for you to implement that?
It's not hard at all. I often implement customer ideas. We put it through the boss, and if we all think it's a good idea as a team, then we add it. And that might be just a few weeks turnaround too. I find there are many subtleties in these installations, and I think you do have to pay attention as a manufacturer to what the customer's doing and how they're using it, and figure out the things that you didn't predict or accommodate for, and then work those in.
All right, the last stop on the tour is the shipping department. And as we walk through, you'll see products lined up and ready to go out, but it's not overflowing or chaotic. They don't have piles of stuff just sitting around collecting dust. When a product is needed, they just make it. They seem to have a good handle on what sells the most, and so they keep those items in stock and ready to ship. It seems like it's a smart, efficient setup that helps them keep things moving without overdoing it or needing a huge storage space just waiting for stuff to go out. So we just finished walking through and looking at just all the different things. And I'll be honest, when I, for some reason in my mind, MidNite Solar, I just thought it was gonna be some small setup. I don't know why, I just did. And I get here and I see this campus of, multiple buildings. They've got, assembly in this building. They've got, engineering in this building. And it's not like little one-room buildings either. It's so much bigger than I thought it was going to be. But it was cool to see because, you could literally go through and just see the different steps in building the different components. And, the other thing is firmware is handled right here. If they've got a problem that needs to be taken care of, their engineering team can take a look at and make changes to the firmware right here, and then they can go through and do all their testing right here. So it was very, very cool to see. It's interesting to see how the different steps come together in order to make a single unit. And so it's not, how much product can we crank out? It's more how much good product can we develop and put out. The attention to detail in watching, even going through some of the different assembly steps, is really very interesting. They're going through their documentation and making sure that every little screw is tightened and torqued down properly. Every connector is secure and tight. It was really cool watching those PCBs go through that, is it a liquid solder bath? yeah, that was neat. And then watching the conformal coating process where it goes through and it bakes that coating right onto the board. So much that I have never seen before. I've torn hardware apart before. I've seen the insides. Can I tell you what all the different parts are? No way in the world. But being able to watch them assemble all of this, it's just very cool to see. If you're interested in learning more about MidNite Solar and the different products that they offer, I'm going to make sure to try to leave links down in the description below for the MidNite Solar website. They do have a forum, even different places that you can buy different products from MidNite Solar from. The next time you need an inverter, a charge controller, you know, things that we tend to overlook is the little surge protection devices on not just the solar panels, but your home as well. Take a look at the different products they offer, because maybe they've got something for you. And you can know that the products that you're looking at were all assembled right here in Arlington, Washington. You know, I hope it's been fun just bringing you guys along with me in taking a look at really behind the scenes of MidNite Solar. So with that, I'm gonna let y'all go. Y'all stay safe, stay cool, and we'll catch up with you later.
Robbie put in a nice floor.
Whoa.
Well, this is a very stupid project, actually. 4 or 5 years, these were supposed to be the B17B batteries, 48-volt batteries, and we were going to put 2 in series to power a 120-volt DC motor. Well, right now the B17 project's on hold indefinitely. So now we're going to create 120-volt modules. I'll show you one of the modules. So this, instead of being an inverter or a charge controller, is going to be a battery. And there's 4 more of these mainframes down here, one behind the seat. And this is what's going to power this car one of these days. What's the end game? I don't know. I just like 57 Thunderbirds.
It's fun.
Yeah, it's fun. It's fun. And it's a big project. And probably a year or 2 years from now, you'll see this thing running. My original goal was to trailer this thing all around the Southwest and let dealers drive it. I mean, who doesn't want to drive a 57 Thunderbird?
No kidding.
Especially one of the only electric 57 Thunderbirds in the world. It's a real show car. We've spent a lot of time on this car. This thing was so rusty when we started, it never ever should have been restarted. There wasn't a piece of sheet metal this big that didn't have holes rusted through it. But Dave Kessler was really good as a bodyman. So he's the one helping to finish this as well. So stay tuned, that's all I can say.
Overall,
and to power the shed, B17s. My brother Bob, which is one of the reasons that the project is on hold, passed away last December.
yeah, sorry to hear about that.
Yeah, he was good. This inverter, each one of these is a 3,500 watt inverter charger. You know, 10,000 watt surge, amazing surge, hot swappable, all that stuff. But he never finished making a charge. One of these modules, this one we think actually charges to some extent. And one of these modules, the MPPT module, actually charges from 600 volt solar. So we're going to power this garage with B17, just because we can.
Why not? Yeah.
Yeah, why not?
When did this start?
We started this probably 4 years ago.
Okay.
Maybe even 5. We've had as much as 4 people working on it at once. We had to extensively modify the frame to get these things to work.
Mm-hmm.
They wouldn't fit. They wouldn't fit under the hood. So a lot of that work was, you can't see it.
Yeah.
Just modifying the frame and whatnot.
And I'm sure repairing, like you said, all the rust and everything.
I'm glad we have a full-time body man on staff. Full-time for at least 2.5 years.
Wow.
On the body and nothing else. And the hood and the trunk, those are over there undercover. But it's, you know, it's an expensive project, so
It's a passionate project now, though.
Yeah. Well, it's supposed to be 17.
Well, and your brother worked on this with you, right?
Oh, yeah. Oh, yeah.
So, I mean, there's that sentimental connection too.
All the engineers are involved on the electronics. And
Yeah.
whatnot. Yeah, they're all involved because they all love it too.
Are you having to do a lot of manipulation under the dash?
No, not a lot under the desk because we'll have a 12-volt battery.
Okay.
All that does work. We can't find the 12-volt battery we bought a couple years ago. But yeah, the headlights work, taillight work, radio works. We may see if we can't soup up the sound system on that. Because my brother and I used to be in the audio business too.
Okay.
Our former life. Yeah, it's just going to be just a daily driver. We don't even have a top for it that works. I'm not sure we'll ever make a top for it. So I don't think I want to take it out in the rain.
No.
You know, not with all this electrical stuff. It's open to the pavement down here anyways. Probably not a good idea to get it real loud.
That's when you almost need like a black punch plate hood.
Well, we may make something down. It'll be charging from a couple of classics. We used to build a 120 volt classic. So we're going to rectify the line and use the classics to actually charge it. And gosh, we'll have a little Rosie in here. We haven't decided if we have to create a 12 volt or 120 volt little Rosie, because the standard little Rosie is 48 volts.
Yeah.
But you know, got a lot of engineers around here, and they like projects like this when they're allowed to. I think it'll be a side project. So that's my project.
Very cool.